Which of the following is true for the definite integrals shown? So we're given three definite integrals labeled j, k, and l. And we have four possible orderings of these things along with simply the number 1. Okay, so I don't think there's going to be much hope of actually evaluating any of these integrals. So I think the best thing to do is essentially sketch them out, sketch what the functions look like, and then compare orderings of the functions. So each of the integrals only goes from 0 to 1, and all of the functions are positive. So I'm just going to graph this like this. Okay, so what are the three functions? I'll even write the integrals out. J is this, 1 minus x to the 4 square root dx. K is the integral of 1 plus x to the 4 dx, and L, integral from 0 to 1 of 1 minus x to the 8 dx. Okay, so when x is equal to 0, all of these functions are clearly equal to 1. We're integrating out to 1. I notice that k is an increasing function, so I don't know, looks something like this. So that's 1 plus x to the 4 square root. The others are decreasing, and I suppose we want to figure out, I may as well draw a line here at 1, because the integral, the area of that square is 1, and the number 1 is one of the things we have to compare to. I mean, we could already, given this, we know that k is greater than 1, and it's going to be greater than each of the other two. We could probably eliminate a bunch of the options, but let's just work out the proper ordering. Okay, so when x is between 0 and 1, okay, obviously this thing is also between 0 and 1, but which of these things is bigger? Okay, for a number between 0 and 1, the higher the power I raise it to, the smaller it gets. So this number, x to the 8, is smaller than x to the 4, but because there's a minus sign, it means this function is larger than this function. So I don't know exactly what it's going to look like, something like this. That's, okay, hold on, which one did I say that is? That's L, right? This is 1 minus x to the 8. And the other one, 1 minus, so smaller power means bigger number, but subtracted means smaller. These are not, the concavity is completely wrong here. I think they both sort of decrease in a concave way. I have not drawn this at all accurately. The only thing I have accurate here is the order between them. So what does this say? Let me label these with colors. That's that, and that's that. So I clearly have, this one is the largest, which is greater than 1. And then I have that one, and then that one. Okay, now let's translate this back into letters. So 1 is less than k. And then the blue one is L, and the yellow one is J. Oh, okay, JL1K, and that's option A in the test. Yeah, if I swap these two, LJ1K, that's also an option. So that's sort of the only other one that's even reasonable to choose here. Yeah, I hope I did this correctly. Let's just verify very quickly. If I choose, let's say x is equal to 1/2, then that's been raised to the power of 4, that's been raised to the power of 8. 1/2 to the 8 is smaller than that. So we're subtracting something smaller, which means overall it's bigger. So I have the ordering here. JL1K. JL1K. Yeah. That'll be my answer. Hope I didn't make any silly mistakes, but if I did, I'll let you know. Thanks for watching.